Good afternoon, everybody. Welcome to the 2 p.m. session of the Partnering Conference. This session is titled Thinking Big, Building Small, KYTC HSIP's first mini roundabout. We have 4 particular speakers in this session. I'm not going to go through their whole bio because it will take too long, I think. But first, we have Nathan Ridgway, a transportation engineering specialist with the Kentucky Transportation Cabinet. He works in the Division of Traffic. We have Joel Morill. He is a senior transportation engineer at Gresham Smith. I was really looking forward to introducing Darrin Eldridge, giving a whole bio on him, but I guess we'll go ahead and cut it short. He is a transportation engineering branch manager in District 9. Seems to me senior should be somewhere in that description, but it's not. And we also have Jeremy Kubac, who is a senior transportation engineer with Gresham Smith. With that, I'll hand it over to the guys.
All right, good afternoon, everyone, and thanks, David, for the introductions. I'm Nathan Ridgway with the Highway Safety Improvement Program, and our presentation today is on our first mini roundabout design, which is at the intersection of US60 and KY801 in Farmers in Rowan County, and it was in the August letting and has been awarded. So it will be constructed probably in the spring of 2021. This particular design, or mini roundabout design in general, incorporates concepts that were used in other states that push the boundaries of conventional roundabout design by utilizing a fully traversable central island and approach splitter islands. This design allows for a smaller inscribed diameter, which fit into our project budget, reduced environmental and utility impacts, and allowed for a fairly quick turnaround between project conception and construction letting. When I think back on this project, I think one of the bigger reasons it was successful at going from conception to completion or letting fairly quickly was the partnering that was done between not only HSIP staff, but also our consultant partners at Gresham Smith, and our District 9 folks really went above and beyond, really took this project on and did well with public involvement, all the design details, et cetera. So it really, in my mind, was a good presentation to present at the partner conference this year. Jeremy, could you go ahead and, okay. So just a brief outline of today's discussion. I'm going to handle HSIP, Highway Safety Improvement Program overview and our initiatives. Joel's going to talk about crashes and countermeasures. Darrin's going to talk about our regional and local significance. Jeremy is going to talk about design and construction considerations. And then Darrin's going to finish the presentation off with the public involvement. So this is a little bit of an older slide, but it kind of shows our breakdown of how we expend our HSIP dollars. So anytime I give a presentation, I always try to give a little background about the Highway Safety Improvement Program itself. It is a core federal aid program established in 2005 with the intent of reducing serious injury and fatal collisions on all public roadways in the U.S. This program distributes funds for infrastructure safety projects that are in line with the state's adopted strategic highway safety plan, are data-driven, and go toward reduction in crashes. Our state distributes a large percentage of our funds toward roadway departure and intersection-related projects because our data indicates that these are the 2 largest percentage of crashes occurring in our state. Roadway departure in particular is the largest contributor to fatal and serious injury crashes in the state as well. For both intersection and roadway departure projects we develop, we assign a consultant, in this case it was Gresham Smith, to study crashes for a particular area and then produce recommended countermeasures to help mitigate crashes. One of the more effective intersection-related projects we can do to mitigate crashes is a roundabout, but historically they've been difficult for us to implement due to our limited budgets. The mini roundabout concept has been used in other states, construction roundabouts that are on a smaller scale that can fit within budget while still effectively reducing crashes and maintaining or exceeding capacity. In HSIP, we have challenged our consultants to look for opportunities for these roundabouts through their crash analysis. Slide 4 just illustrates the kind of the fundamentals of the mini roundabout, where it shows the fully traversable central island. Key features is that you want something opposing enough so the passenger cars can have some deflection, but also not as imposing where a tractor trailer can traverse the central island. You can proceed, Jeremy. Some other benefits, particular for us, roundabouts in general provide a traffic safety benefit because they reduce crash severity, mainly because the entry angles of the vehicles are changed or left turns are eliminated. This usually leads to, if there is a crash, it's usually less severe rear end or side swipe collision. Traffic calming is provided due to the central island providing deflection of the vehicles. So entering vehicles need to slow down to maneuver through the roundabout. The main benefit for the mini roundabout compared to others is the compact size. When you can fit something within right-of-way and minimize environmental and utility impacts, usually you will have a pretty quick project turnaround and have a reduced construction cost. Mini roundabouts don't necessarily have to be just plain. You can provide aesthetics such as colored concrete and stamping, which we did for this project because of the area itself. You can have some access management that you can look at doing with these with the splitter islands. And then the other main environmental benefit is the compact size again, just limiting staying on right of way, limiting getting off right of way, and potentially having environmental impact that could prevent the project itself. So I'm done. I'm going to turn it over to Joel.
Okay, thank you, Nathan. Just a little project overview. US60 is a 55-mile-an-hour, 2-lane rural roadway with an ADT of approximately 4,000 vehicles and travel lane widths between 10 and 12 feet. This 5.5-mile-long segment of US60 was assigned to Gresham Smith as a roadway departure corridor due to its excessive roadway departure type crashes. But after a detailed crash analysis using the CCAT, which is the Systemic Crash Analysis Tool, the design team discovered that instead of there being systemic safety issues along the entire corridor, there were actually 2 hotspots where most of the crashes occurred, especially the injury ones. The first hotspot was a compound curve with 3 widely ranging radii. Within the 5-year study period, 28 roadway departure type crashes occurred in this compound curve, all of which involved a vehicle losing control in the westbound direction. The recommended safety improvements to this hotspot included realigning the curve to have a single radius to provide a more consistent and predictable roadway environment for drivers. The second hotspot was the US60 KY801 intersection. Within the 5-year study period, 10 crashes occurred, 4 of which were injury, and 7 of which were angle or T-bone crashes. This T-bone type of crash at an always stop intersection typically indicates a driver blowing through the intersection and often involves serious injuries or fatalities. So when identifying the potential countermeasures for safety on a roadway with excessive crashes, we must not only know what happened, but why. What roadside, roadway, or environmental features or factors could have contributed to the crashes? Looking at this intersection's location relevant to the surrounding area, we believe its remote location could be a contributing factor to drivers blowing through the intersection. From the west, it is a first stop controlled intersection in 10.5 miles. And from the east, it is the first stop controlled intersection in 7 miles. We believe drivers are either surprised by or unaware of the intersection until it is too late. So our discussions with District 9 confirmed that this intersection has been a safety risk for some time. Through the years, District 9 has implemented many incremental proven countermeasures to address the safety issues. These improvements include transverse rumble strips in 3 of the approaches, double stop ahead signs, one of them with flashers, double and oversized stop signs, and ultimately overhead red flashers in all directions. Yet T-bone crashes continue to occur. So our design team decided to examine the intersection's crash history further back to see if there's been a measurable, consistent improvement in the safety performance since these safety countermeasures had been implemented by District 9. And what we found is there had not been. In fact, more crashes, including serious injury ones, occurred in 2016 than in any other year in the extended study period. All of the safety countermeasures I mentioned earlier were in place in 2016. This is when the project team decided something new, something innovative needed to be done to address the crash issues at this intersection. This is when the US60 Kentucky 801 mini-roundabout concept was born. And while we believe that a mini-roundabout would be an effective safety solution, traffic and access to and from nearby I-64, Cave Run Lake, and Daniel Boone National Forest needed to be studied in partnership with District 9 and local stakeholders to verify that a mini-roundabout was indeed a feasible option at this intersection. And I will now pass it on to Darrin to talk about the context of the intersection.
As shown on the slide, when an incident occurs between exit 123, which is Bath County, Salt Lick, exit 133, which is Round County, Farmer Sharkey, and exit 137, Round County, the Moorhead exit, that requires a temporary closure of I-64 and the detour of its traffic, US60 and Kentucky 801 are used. ADT along this section of I-64 ranges between 20,000 and 21,000 with about 20% trucks. The design team agreed that construction of the mini roundabout had to accommodate the additional traffic of an I-64 detour. Detailed maintenance of traffic plans and notes were developed which ensured that the US60 Kentucky 801 intersection would remain open or could be immediately opened if an I-64 detour was necessary. Furthermore, the intersection had to accommodate the large number of trucks, including overweight and overdimensional. The US60 Kentucky 801 intersection is the primary gateway to Cave Run Lake and the Daniel Boone National Forest. If you're familiar with that area, you know that how significant it is to the region. Cave Run Lake is approximately 8,270 acres, while the Daniel Boone Forest is approximately 700,000 acres, and they host thousands of tourists each year who will come to use the 12 boat ramps, 400 campsites, and enjoy boating, camping, fishing, hiking, picnicking, hunting, horseback riding, scenic driving, or basically you name it, they do it over there. The project team recognized the regional importance of this area and provided a design that would allow these recreational activities to continue throughout the duration of construction and would enhance safety and accessibility after construction.
As with any roundabout, the design vehicle turning movements played a key role in developing the proposed geometry. You have to balance the need to reduce the fastest path speeds of passenger cars while still accommodating the largest expected vehicles. We chose to design for the WB67 that the US60 and Kentucky 801 are frequently used as an alternate route for I-64 during traffic incidents. Our goal was to develop the tightest geometry that would allow the cab to navigate the circulatory roadway while letting the trailer track over the mountable central island. The fully traversable central island made it possible to accommodate the WB67 with a 90-foot inscribed diameter. Outside truck aprons were designed to contain the tracking beyond the outside lip curb, primarily due to the right turn movements. A less common design vehicle is a motorhome with boat trailer. The proximity of Cave Run Lake meant that this combination was very likely to traverse the roundabout from all directions heading to and from the lake. As such, the design team checked the geometry to ensure that it would accommodate the vehicle tracking. At first glance, it would seem that the geometry used to accommodate the much longer WB67 would accommodate the motorhome with boat trailer by default. Surprisingly, however, it's the steering of the motorhome in the AASHTO model that limit its path, with a larger turning radius than the WB67 rather than the drag of the trailer that ultimately controls its swept path. While the WB67 is able to approximately follow the outside edge of the roundabout in a circular path, the motorhome must take a more elliptical path, taking advantage of the outside aprons when attempting left turns. This is a view from the design model with materials applied to the surface. All of the vertical elements within the roundabout have the standard KYTC lip curb profile. The monolithic central island is fully traversable and constructed with stamped and colored concrete to provide a visual cue to those approaching, as well as tactile feedback to those traversing it. The outside truck aprons, also colored and stamped, are constructed adjacent to the outside lip curb and gutter at a non-uniform width to approximate the combined swept path of both design vehicles. Finally, the splitter islands are also fully traversable. However, none of the design turning movements cross them due to the potential conflict with queued vehicles. Making the splitter islands traversable allows wide loads and special permitted deliveries to negotiate the intersection with assistance from pilot vehicles. While the four approaches all have rural typical sections, the channelization necessary to control speeds entering a roundabout requires curb and gutter. In order to minimize the amount of wedging necessary to maintain an acceptable cross slope and longitudinal gutter flow, a detailed elevation development plan was included in the bid set. The use of curb and gutter in turn created small areas of concentrated flow that had to be accommodated. In lieu of catch basins and storm sewer, the design team pursued the use of flumes and riprap aprons to outlet the gutter flow and dissipate energy while keeping all maintenance activities and excavation at the surface. Due to the existing pavement grade, it was not possible to push the flumes outside the truck aprons. As the standard KYTC flume is intended to be behind guardrail and is not traversable, a new special traversable flume detail was developed specifically for this project. Early in the project, existing utilities were identified and mapped. The project site has water, gas, sewer, and overhead electric. While the nature of the construction was such that only shallow excavations would be necessary and underground utilities likely would not be impacted, the overhead utilities had an impact on design. The design team worked to keep the construction completely within the existing right-of-way while avoiding all of the adjacent utility poles. Knowing that US60 and Kentucky 801 serve as an alternate route for I-64 during traffic incidents meant that a detailed construction sequence and traffic plan would be necessary for the construction team to be prepared for an incident on I-64 during construction. As the intersection already had left turn lanes, there was sufficient pavement width to maintain two-way traffic in the all-way stop configuration while constructing the outside gutter, truck aprons, and any necessary pavement widening during the first phase. In the second phase, traffic is shifted to the roundabout circulation while the central island is constructed. Truck traffic is discouraged from entering the site via variable message boards at upstream and downstream interchanges. In the event that a truck makes it to the site and cannot make the left turn movement, the contractor is to guide the truck through the roundabout in a contraflow manner to the left of the central island with flaggers. The previously constructed truck aprons will be utilized for this movement. In the third phase, once the central island is cured and is able to carry traffic, the roundabout circulation continues while the splitter islands are constructed. Finally, in the fourth phase, final surfacing is placed throughout the roundabout using flaggers to maintain traffic. In any roundabout, one of the major benefits is the reduction in angle or T-bone crashes. When crashes do occur in many roundabouts, they're more likely to be sideswiped due to the approach angles of conflicting movements. This trade-off replaces many fatal or serious injury crashes with property damage only crashes. The combination of signs, markings, and geometry through visual cues is designed to passively influence better driver behavior. Further, operations should see an improvement over the all-way stop condition. Given these benefits, the mini roundabout will still be able to accommodate I-64 detour traffic as well as recreational vehicles while staying completely within the existing right-of-way. And now I'm going to turn it back over to Darrin.
A local officials stakeholders meeting followed by a public meeting was held in February of 2020. Approximately 70 people were in attendance. 50 were public and local officials. About 20 were Gresham Smith and staffing, as well as KYTC staff. Although 20 sounds like a lot of representation from the consultants and KYTC, we felt it was important to show support for the project, which included representatives from HSIP, all divisions of District 9, and have the expertise of several consultant staff to answer technical questions. Some of the KYTC staff were from the area, so that added personal knowledge to our representation. Gresham Smith presented the crash history of the intersection and reviewed the countermeasures that KYTC had implemented. The mini roundabout concept was presented along with the expected benefits. The presentation explained how mini roundabouts work, and videos were shown that demonstrated how all types of vehicles could traverse them. Mini roundabout informational flyers were provided to those in attendance, and the meeting ended with a question and answer session. Prior to the local officials, stakeholder, and public meeting, Alan Blair, the District 9 Public Information Officer, provided press releases, Facebook posts, newspaper articles, and even a radio and TV spot touting the proposed benefits of this safety project, and particularly the mini roundabout. Basically, Alan hit all the media outlets in the area and worked diligently to get good information out to them. Furthermore, Alan included detailed project information, including renderings to the local officials and stakeholders, which accompanied their invitations to the meeting. In other words, we basically sent them something out before they got surprised at the meeting to make sure that they were on board. The project has been led to construction and awarded, but the pre-construction conference has not been held, and the project schedule is unknown at this time. It's probably going to start up next spring. Alan is working on a web page specifically for this project and will provide project updates as well as educational information concerning mini roundabouts. Our goal is to educate the public on how roundabouts work, how to drive through them, and the expected safety and accessibility benefits that they provide. The web page will provide a means for the public to ask and receive answers to any questions they may have. This project demonstrates how teaming and partnerships are key to success. Beginning with a diverse project team that included Central Office HSIP, Gresham Smith, and district representatives from planning, design, traffic, construction, and public information. All members worked together to provide a thorough review and public involvement plan. To provide a thorough review and to ensure that all issues were addressed. Furthermore, a comprehensive local official, stakeholder, and public involvement plan facilitated early buy-in for the project. Overall, the project development process went extremely well, and I believe that everyone feels like their concerns were vetted and implemented. Okay, that really concludes the presentation. If you have any questions, type them in, I guess, in the chat. Does anyone from our group want to say anything else?
Yeah, Brent Sweer posted a question about lighting. We did provide lighting for the roundabout. We went with our design services branch to do that design. Ted Swanser's group. They did it, and we put it in the proposal. And then Brent's got to follow up with any right-of-way needed. We did not need right-of-way for this project. Everything pretty much fit in the existing footprint. I will say, apologize for it being a little short. I think we felt like we went longer in practice, but thanks for everybody for coming out, and we can hang out for more questions or just let us know.
I guess we should have had Mr. Moses read our bios.
I was thinking that. I was like, maybe he should have read our bios. So Steve DeWitt asked if we have more mini roundabouts on the horizon. Yes, we do. We have some in the works in District 4, and we will always look for opportunities to do more in the future.
We're in District 9, we may be looking at, I don't know, we were talking about this yesterday with HSIP, Nathan and Mike, but we're looking at a similar situation possibly for a full roundabout. It may not be a roundabout, but it's something that we're going to look at. So it was something that we were really excited about this project early on. And, you know, I live very close to this area, probably about 8 miles from there. And this intersection has always needed something. You know, we've seen people blow through it over time, and you see people just that don't know how to work don't know how to drive at a four-way stop. They think the person in front of them is going to go, they should go. So you may have 3 or 4 go in one direction while others are just sitting there. And I really attribute that to a lot of the tourist traffic in the area coming to the lake. But anyway, you know, early on when we talked about a mini roundabout there, I thought it sounded like a great idea. And you know, with Grisham Smith's help and expertise, along with HSIP, we were really excited to do this project, and I'm really looking forward to seeing it built and seeing how it works. I think everybody's going to be very, very pleased with how this opens the area up and reduces the severity of the accidents.
So we had a couple more questions pop in. I'll handle the easy ones, I guess. Andrew Brown asked what was the construction cost awarded bid. I think it ended up being over 600,000, right, Darrin? I think.
Yeah, Nathan, it came in. It was a little high. Well, it was very close to our estimate. It was a little higher than the engineer's estimate.
Yeah. Brent asked, will there be a statue of Darrin in the center? No, because it'll get knocked over with the first truck.
Yeah, Brent, I said we were just going to do basically a portrait of me, but we figured that would cause accidents. So we're going with just the standard. It's kind of a red and tan. Is that right, guys?
Red,
Yeah. It's a Baja red.
Baja red, yeah.
Mm-hmm.
There's more questions that we haven't answered yet, but it's probably more maybe Jeremy or Joel questions. I don't know if you guys saw the Q&A portion that you can pull them up.
Let's see. Okay. Okay, I'm trying to go back and see which ones. Okay, so the question about the ratio of traffic approaches, this particular roundabout wasn't approached necessarily from a traffic demand standpoint, or in order to address a traffic demand, but more so to address a safety concern that basically is a traffic calming device. And typically you wouldn't use a mini roundabout, or the more recent guidance was that you wouldn't use a mini roundabout where you had a higher percentage of trucks like on this facility. But this is an emerging practice that came out of there was a concert that several of the HSIP team members attended in Michigan, where they're starting to use the mini roundabout in areas with higher percentages of trucks successfully. So, we weren't approaching this from a traffic demand standpoint, but more so from as a safety measure. If that answered that question.
And if anyone, when I was talking about the truck percentage, I was talking about the 20% trucks is on I-64. That is not the truck percentage on 60 in Kentucky 801. But if I-64 is closed and we have to use this facility as a detour route, then we do have 20% of the 20,000 going through this area. So that was the importance of being able to provide a design that would accommodate all those trucks in case of a I-64 closure.
I think John Moore had a question: what is the anticipated breakover between mini and full roundabout? And I guess my interpretation is at what point do you go from a mini to a full? And I think that line has been kind of blurred now, where previously when we would have looked at this and looked at probably 7 or 8% trucks on US60, we would have immediately discounted the mini roundabout and gone to a conventional single lane roundabout. That thinking has kind of been turned upside down, and that's why we pursued it based on experience of others, especially up in Michigan. I guess where I would start to really push towards a more conventional roundabout is if we had pedestrian movements. What this has done in order to use a mini roundabout and to get any type of truck traffic through it, it does require significant truck aprons on the outside. And that's what, in Michigan on some of those roundabouts, they actually had to, after they built them, they had to go retrofit with truck aprons. We've designed it for that, but when you have pedestrian movements, those outside truck aprons start to cause problems because where your pedestrians are queuing up is now in the path of a vehicle. So at that point, if we had a lot of pedestrians here, I would and had to accommodate the trucks, I would immediately go to a conventional roundabout. But in this rural setting where there's no pedestrian facilities in sight, this was it was a good fit, but only with this new guidance or this new approach that others have taken. Another one. Are you finding the public more? This is Steve Hall. Are you finding the public more receptive now that we have some roundabouts on the ground and that it's not this crazy concept that some stupid engineer came up with? I'll answer first, but I want the others to weigh in on this too. But I think absolutely in the communities where they've been added, I live in an area and frequent some areas where the idea of a roundabout would just people would be completely dismissive of it. But once they're in place and people figure out how simple the operation is and that you don't have to stop to wait for nothing, that's the most apparent thing that most people figure out. If you can get them to listen to you, in terms of eliminating T-bone crashes, I think, you know, a lot of people, when they have that aha moment, it really makes sense to them. But for somebody to, you know, one of the things they can experience on their own is the fact that they don't have to sit there and stop for nothing. Unless if there's somebody coming, then you wait. If not, you just go. And that's, I think, the biggest selling point for a lot of people that aren't in the industry. So I'm going to turn it over to whoever wants to answer next.
Well, the part about talking about Alan Blair and the public involvement plan, Alan got up on top of this early and got the statistics of roundabouts out to the local officials and stakeholders. And I think that got them talking to the public, because a lot of people knew about this prior to the public meeting. So when we went to the public meeting, of course, Gresham basically started off with, you know, all the technical stuff, if you will, and animations, and basically talked about how well they work. We had an extremely good buy-in at the meeting. We only had one public person who tried to basically say, you all are out here trying something new. We're the guinea pig. I think he might have even used those words. But the surprising thing that happened at that time is one of the local officials or another member of the public said, look, you've seen the numbers on this. This is the right thing to do here. And they basically defended this design without us even saying anything. If you guys remember that, that kind of stood out to me. But I guess the point I want to make, though, is getting the information out early on this was probably the key to getting the buy-in and acceptance from the public. We tried to do education prior to just, you know, telling them what we were doing.
I think some folks are putting some questions in the chat too. Saw one from Robert Brown about advanced warning. We upgraded all signs on all approaches, Robert, including a roundabout warning sign. And then we also lengthened the splitter islands on 60 to provide more kind of vertical positive separation, more notice. And then it even included some posts, some delineator posts are pretty robust, but not very tall. So kind of like get some extra vertical on those splitter islands. So we tried out different things, plus color in the concrete for contrast to just make people aware that there's something different here and look to be doing a yield condition before entering into the roundabout.
When we were working on another roundabout project that we have in Nicholas County, it's a full roundabout, but during the public meeting for it, one of the major concerns that we heard about the Cynthiana roundabout, which is fairly close to District 9, that there wasn't a lot of warning going into it. People were kind of not expecting it to be there. It's in a rural area. So we basically learned from that and applied a lot, like Nathan was saying, we applied a lot of warning out there with reflective, through the use of reflective, did we use placards or bowlers? I can't remember on that. The flat panels, maybe.
Pesco City posts, little delineators.
Yeah. We use the higher reflectivity beads, I believe, on this as well, or at least the rain beads. So the stripe will be brighter. And it'll be lit, like you mentioned earlier too. So
speed bars, Darrin, too.
The speed bars. That was something new. Jeremy, you want to talk about those?
Sure. Yeah, and if hopefully you can see it on this rendering here. If you look at the west leg, they're little 6-inch pieces of striping that are perpendicular to the outside edge of pavement and inside edge of pavement, and they start at about a think a 15-foot spacing. And as you approach the roundabout, their spacing decreases. And it's just another indication that you're going from a high-speed facility to a slower movement roundabout. And this is the first time that we've used that particular marking on a roundabout in Kentucky, and this just because of the situation that you're in on a high-speed road, and to give greater driver awareness.
Yeah.
Brad Bonham's asked about lighting. We did have Ted Swansiger did some lighting design for us. That's about it.
There's a question about will tow beds hauling heavy equipment be able to clear the center island?
That's a
fantastic question.
Great question. We actually have a quarry in that area, meaning that, and that's why I mentioned the overweight, overdimensional, both from, I didn't mention this actually. The overweight to overdimensional that I mentioned earlier was more for the I-64 detour. But the quarry occasionally hauls way overweight, overdimensional things through there by permit. And they are on low boys that have minimal clearance. So Jeremy, Joel, y'all want to talk about the lip curb on that?
Sure. In the past, we've sometimes used lip curb, other times used the KYTC median curb, which is actually 4 inches tall. This lip curb is 3 inches tall, laid back over 9 inches. And so it's a very easily traversable curb. In fact, it's even been used on turning lanes in some areas where you merge over it. So we started with that, trying to reduce the impact of when a vehicle does have to go over it. But we also try to make the tabletop, the inscribed diameter of the roundabout fairly flat, which you still need to provide some longitudinal grade for drainage, and at the same time we're trying to save as much pavement as possible. So we ended up with a fairly flat profile, which makes it easier for those vehicles, without a breakover to worry about. So the biggest obstacle is that 3-inch tall lip curb, but so that's really about the softest barrier you're going to find. I guess I'll keep talking beyond until somebody else has a question. Beyond that, on those outside truck aprons, those can be used if you have a large permitted load coming through, where you've got a pilot vehicle, and where you can direct traffic. There's a lot of different options for how you can get through that roundabout, and even in the contraflow direction, utilizing that, basically going to the left of the central island if you need to. So those deliveries that are planned ahead, you can make all kinds of adjustments within this footprint.
Yeah, that was a good question. That's something that we spent quite a bit of time addressing early on in design.
Okay, but there's another question down here. Did the local public agency request the mini roundabouts, or do engineers recommend this action?
Ask the question again, Jeremy. I may have misunderstood.
Did the local public agency request the mini roundabouts, or do engineers recommend this action?
I guess the best way to talk about this is, when we were looking at, the project, Nathan, and, its accident rate made it an HSIP project. So basically we went into it looking at, some way to reduce the accidents. Not necessarily a mini roundabout. We were open to it. But as we started applying different Well, we basically, like Joel talked about, we've applied almost every countermeasure that we can to the existing four-way stop, and it's not been successful. We were pretty much out of traditional improvements to do there. So the mini roundabout was really was an engineering decision early on, but it also, with the early buy-in from the local public officials, local officials, it kind of became both. I mean, they're excited about it as well as we are, which is kind of surprising. I'm really pleased about the reaction that we got from the local officials and the elected officials about putting a roundabout there.
We've got another question here. Can a mini roundabout be upgraded to a regular roundabout in the future so the public is familiar with this intersection type? You know, so the inscribed diameter is, if you look at that image there, where on the outside you'll see the dotted white line at the approaches. So that's a 90-foot diameter there. When you go to a conventional, you're probably going to jump up to, you know, a minimum of say 120, 130. And then you would have on the inside a partial truck apron, but then the center of the central island would not be traversable. So you could use parts of this. So especially if you initially designed a full roundabout and then set your grade on the mini roundabout so that it was basically on that surface, and then you would end up removing a lot of, you know, your outside truck aprons and reconstructing that as pavement. So it wouldn't all be lost, but as long as you set your grade of the mini roundabout such that you could build outward to the full roundabout, and you could partially use it. Same, you know, with your lighting, if you plan that ahead and put your light poles out far enough that they could still adequately light the mini roundabout, yet would be out far enough to be outside the footprint of the full roundabout, you might be able to do that. But you definitely want to be planning that ahead or designing them both at the same time, or at least have an idea of how big the full build out would need to be.
If we ever decide to upgrade it to a full roundabout, I could definitely get my statue out there, but people would probably think it was a hippie Buddha out in the middle, and that probably wouldn't work very well.
A traversable Darrin.
Yeah.
Okay, let's see. Aaron McCown here. Jeremy, the approach angles of the roundabout are pretty straight on. Did you implement any other speed scrubbing measures to reduce speed upon approach if the speed was an issue? So the main thing we did in approaching the roundabout, you know, from further back, we maintained the existing, or actually freshening up the existing thermoplastic rumble strips. We added the speed bars, which the block striping that's on the inside and outside edge of pavement approaching from each leg. And then as you get to the roundabout, the geometry there was developing that entering geometry is an iterative process. We start with the truck movement. Basically, we'll run auto turn through there to get the truck into the roundabout without hitting any, basically so that the cab doesn't hit any of the curbs. And then we allow the trailer to drag over where necessary. Then we go back and develop the fastest path analysis. And that's where we're trying to see, you know, if a car can blow right through there or not. And we actually found of the four legs there, the most difficult one was the 801, the south leg of 801. And that's the one, if you look, it's in the, I guess, the southeast corner of the picture there. And because that leg approaches basically, you know, in the, as almost tangential to the roundabout. And so that's, if you notice, there's a little squiggle in there, and that's, we had to push the traffic out, bring them back, and then bring them back in order to induce some deflection going into the roundabout. And so that's, it's not a straightforward process. I know there's, you know, there's software that'll just throw a roundabout in. And you can just sketch one in. But until you balance the vehicle movements versus the actual path of smaller vehicles, you really got to run those back and forth and refine your design to get that deflection that's needed. That's a good question.
How's that for timing?
That's dead on.
Thanks everybody for coming and providing good questions.
Mm-hmm.
Guess we'll be hearing from David one last time. All right.
Oh, I think David left the webinar to go on to the next one. If there's no more questions, we'll just go ahead and end it. Thanks,
Great.
guys.
Thanks everybody.